everyone, I am Divya, your math facilitator, and in this video we are going to learn about real numbers, which is chapter 1 of class 9, and we have already learnt a little about this chapter in part 1, and now this is part 2 of the introductory video. So if you have not watched part 1, then do watch part 1 too, because you'll have a continuity of this chapter, and in this video we are going to learn these contents. Now in the earlier video we have learned what are the different set of numbers like natural numbers, whole numbers, integers, rational numbers and irrational numbers, and we have concluded that rational numbers plus irrational numbers will give you the set of real numbers. Now in this video, firstly let us learn how to represent irrational numbers on number line, because in your earlier classes you have learned how to represent natural numbers on number line, whole numbers on number line, integers on number line, and in 8th class you have learned how to represent rational numbers on number line. So now firstly let us learn how to represent irrational numbers on a number line. Now let us represent root 2 on number line. As you all know that root 2 is a irrational number, yes. So let us represent this on the number line. So firstly you will draw a number line, okay, and mark points 0, 1, 2, 3, 4 and so on, and this side is -1, -2 and so on. So you mark the points with a unit distance from each other, okay. 0 to 1 it is unit distance, 1 to 2 it is unit distance, which means a fixed distance between the numbers, okay. So now the first step is we shall draw a square of side 1 unit, okay. So a square of side 1 unit length, and we shall start from this point, okay, 0. Let this point 0 be O, okay, and 1 let it be as A, okay, we are marking it as A. Now O to A it is 1 unit distance, okay. So this is one side of a square, yes. So similarly I will draw a square of side 1 unit length, okay. So this is 1 unit and we shall take, now this is a square of side 1 unit, okay. So this is 1 unit length, clear. So let us mark the other points as B and C, okay. Now let us draw the diagonal of this square OB, okay. Now you can see that OAB is a right angle triangle, yes. So from Pythagoras theorem let us see what is OB, okay. So this is a right angle triangle and right angled at A, clear. So this is the right angle. Now this is AB and this is O, okay. How do you get this hypotenuse? Now this is 1 unit and this is also 1 unit. So hypotenuse you get it by under root square AB square plus AO square. So it is 1 square plus 1 square, which is nothing but under root 1 square is 1. So 1 plus 1, so this is under root 2. So OB is root 2, yes. So this is root 2, clear. Now we want to mark root 2 on the number line. So what do we do? Now this length OB is root 2. Now what you will do is you will take a compass, okay. You have compass in your geometry box. So take that compass and measure, place the end of the pointer of the compass here at O and the other end, the pencil end of the compass at B, yes. And now measuring this distance, okay, without changing the radius of the compass, measure this distance and then mark this distance here, okay. So now if these are the two ends of the compass, so you will place one end here and the other end here, okay. Now without changing the radius and without moving this point, now you will just mark an arc here, okay. Now this is nothing but root 2, okay. This is nothing but root 2, okay. Now this distance OB and this distance should be same. So you have marked root 2 on the number line, clear. So this is how you can mark irrational numbers on the number line, and let us take another example. Now if I want to mark root 3 on the number line, how can we do that? So firstly you will mark root 2, okay. Even to mark root 3 on the number line you need to mark root 2 first, okay. So this procedure is same. You will draw a square of 1 unit length and you will find what is the hypotenuse. Now this is a right angle triangle, you will find the hypotenuse. It is nothing but root 2, okay. Now this root 2, using compass you are taking the radius as the length of OB and you are drawing an arc to cut the number line between 1 and 2, okay. This is root 2 on the number line. So now for root 3, firstly you will mark root 2, and now what you do is you draw a perpendicular at the point B, okay, and this perpendicular should be of unit length, okay, the same units, the same 1 unit length, okay. Suppose this is D, okay. Now join OD. So simply you join OD. Clear? Now you can see that this is also 1 unit. Yes, so we have drawn a perpendicular of unit length to OB, okay. So BD is 1 unit and this is perpendicular to OB, that means this angle is 90 degrees, okay. Now you can see that OBD is a right angle triangle. Yes, so OBD is a right angle triangle and right angle is at which point? It is at point B, okay. So right angle is at B point, okay. So this is D and this is O. Clear? Now if I want the distance, the length of OD, how do you get it? By the same Pythagoras theorem, yes. So here you can see BD is 1 unit and OB is root 2. Yes, so using Pythagoras theorem, OD is nothing but under root 1 square plus root 2 whole square, okay. So it is nothing but BD square plus OB square, which is 1 square plus root 2 whole square. So this is nothing but under root 1 square is 1 plus root 2 whole square is what? It is 2. So it is under root 3, okay, which means OD is root 3. Now the same process as we have done for root 2. Now take a compass and place the pointer of the compass at O and the pencil pointer at B, okay. Using this distance as radius, you draw an arc, okay. This arc will cut somewhere here on the number line, okay. So this is nothing but root 3. So this arc is cutting the number line here at this point. This is nothing but root 3. Clear? That means the distance OD is equal to O, and if you write some point here Q, so it is OQ. Clear? So this is how you can mark irrational numbers on the number line. And to mark any irrational number, now you see, to mark root 3 you have firstly marked root 2, yes or no? So if I want to mark root n on the number line, then firstly I have to mark what? I have to mark root n minus 1 on the number line, okay. Now here to mark 3 you have marked 2 first, okay. 2 is nothing but 3 minus 1 is 2. Clear? So similarly, if you want to mark any number, say root n on the number line, so firstly you have to mark root n minus 1 on the number line. Yes. Now suppose if I want to mark root 7 on the number line, then what should I mark first? I should firstly mark root 6 on the number line. Yes. Using the same method, this continues. Okay, so this is root 2, next you have root 3, then you will get the next number. So this method continues, and after marking root 6 you will be able to mark root 7. Clear? Nothing but after marking root n minus 1 on the number line you will be able to mark root n on the number line. Now the next concept is how to insert irrational numbers between any two numbers. Okay, so we have learned that there are infinitely many rational numbers between any two rational numbers in class 8. Yes, so similar to rational numbers, there are also infinitely many irrational numbers between any two numbers. Okay, so now let us see. Now suppose for example I have taken 1 by 3 and 2 by 5, and let us mark irrational numbers between these two rational numbers. Okay, let us insert irrational numbers. So how can we do it? Now 1 by 3 is nothing but 1 divided by 3. Yes, so you cannot divide 1 by 3, so you will put a decimal point. Okay, now it is 3 3s are 9, so subtracting you will get 1. Again you can write as 0 here, so it is again 3 3s are 9. Again you get a remainder 1, and you know that this is non-terminating decimal. Yes, so it is 0.333 and so on. So 1 by 3 is nothing but 0.333 and so on. Yes, now what is 2 by 5? 2 divided by 5, it is nothing but 0. Now you know that 4s are 20, so 5 4s are 20. Okay, so 2 divided by 5 is nothing but what? 0.4. Yes, so we have two numbers, 0.333 bar and 0.4. so between these two numbers you can insert infinitely many irrational numbers. How? For example, you can take any number between these two numbers like 0.341876, so on. Okay, this is a irrational number because it has a decimal part which is non-terminating and non-recurring. Okay, another example you can take 0.3917648719 and so on. Yes, so in this way you can take any number of irrational numbers between any two numbers. Okay, now the second type of problems which you may get is to insert irrational numbers between any two rational numbers. Okay, suppose 5 and 6 are any two rational numbers and you have to insert irrational numbers between them. The easier method is you can take the root of the product of these two numbers. Okay, 5 into 6, which is nothing but root 30. So root 30 is a irrational number between 5 and 6. Okay, suppose if there are two rational numbers a and b and you want to insert irrational number between a and b, then you can just take the root of product of these two numbers. Okay, and you can say that root ab is a irrational number. Okay, the condition is that a into b, this a into b should not be a perfect square. Okay, now here you can see 5 into 6 is 30. 30 is not a perfect square, so simply you can just multiply the given two numbers and take the root of it, and you can say that root 30 is a irrational number between 5 and 6. Okay, so this is a simple method provided when 5 into 6, this a into b is not a perfect square number. Now let us take few examples to understand the operations on real numbers. Okay, operations are nothing but addition, subtraction, multiplication and division. Okay, how do these operations affect the real numbers? So now suppose root 3 plus minus root 3, if I have to add root 3 and minus root 3, then the answer is what? The answer is 0. Now you know that 0 is a rational number. Yes. Now root 2 minus root 2. Okay, now what is the answer? The answer is again 0, which is again a rational number. Yes, and what is root 3 into root 3? Root 3 into root 3 is nothing but 3. Yes, so the answer is a rational number. You have taken two irrational numbers and you got a rational number. Now for example, root 7 by root 7. Yes, so the answer is 1. Now 1 is also a rational number. So you are adding two irrational numbers, you are multiplying and you are subtracting, or you are dividing two irrational numbers, but the answer need not be a irrational number. So the answers which you are getting are rational numbers. So irrational numbers are not closed under any of these operations. Okay, not closed under addition, not closed under subtraction, nor they are closed under multiplication and division. So what is the closure property? If a and b belong to irrational numbers are represented by q dash. Yes, then a plus b also should belong to irrational numbers. Okay, and a minus b should belong to irrational numbers, a into b should belong to irrational numbers, and a divided by b should belong to irrational numbers. But these conditions are not satisfying here, so you can say that irrational numbers are not closed under addition or subtraction or multiplication or division, because when you are adding two irrational numbers you are getting a rational number. Okay, sometimes, so it is not necessary that you always get a rational number or you get a irrational number when you are adding two irrational numbers or when you are multiplying two irrational numbers. Now if you want to add a irrational and a rational number like root 3 plus 2, yes, so you know that root 3 is 1.732 and so on, and you have a plus 2, so the answer is 3.732 and so on. So this is also non-terminating, non-repeating decimal, so this is irrational number. So you are adding a irrational and a rational and you are getting a irrational number. Now if you multiply a irrational and a rational, okay, root 3 into 2, then what do you get? You get 2 root 3. Now 2 root 3 is a irrational number. Okay, now suppose if you want to divide a rational and a irrational number, so the answer is root 7 by 2 is a irrational number. Yes, and similarly if you subtract also you will get a irrational number. That means a rational and a irrational, if you are doing any operation on a rational and irrational combination, the answer you are getting is always a irrational number. But if you are adding or subtracting or multiplying or dividing two irrational numbers, the answer can be irrational or rational. But if you are doing the same operations on a rational and irrational combination, then the answer is always irrational number. The next important concept of this chapter is rationalizing the denominator, and most frequently you get problems on this topic. Okay, so what is rationalizing the denominator? So let us take an example 1 by root 3. Okay, now it has a numerator, it has a denominator, and this denominator is a irrational number. Yes, root 3 is a irrational number. Now the concept is you have to rationalize the denominator. Okay, that means this you have to rationalize, that means you have to convert this denominator into rational number. The denominator you are having here is irrational number, you have to convert it into rational number. So how can we do that? So you already know that root 3 into root 3 is what? It is nothing but 3. Yes, how do you get 3? So it is under root 3 into 3. Yes, which is nothing but under root 3 square. Okay, 3 into 3 is 3 multiplied 2 times is 3 square. So square and square root gets cancelled and you get 3. Okay, so this is nothing but, if you want to generalize, the formula is root a into root b is equal to root ab. Yes, so using this formula, this property, we are doing this. Okay, so similarly now you can see that if you multiply root 3 with another root 3, you will get 3, which is a rational number. Okay, so let us multiply this with root 3. Okay, but you have to be cautious that you should never change the original value. Yes, so in order to not to change the original value, you will multiply and divide with the same number. Okay, so root 3 divided by root 3. Now root 3 divided by root 3, it is in the form of root a by root b. Yes, so this is nothing but under root a by b. Okay, so see, now this is root 3 by root 3. Root 3 by root 3 is nothing but under root 3 by root 3. Yes, so 3 ones are 3 ones are. So it is root 1, which means 1. Yes, so this value, it is nothing but 1. That means multiplying 1 by root 3 with 1 will give you the same value. Yes, so we are multiplying and dividing with the same number so that the original value doesn't change. So multiplying and dividing this, what do you get? 1 into root 3 is root 3 divided by root 3 into root 3. You already know that root 3 into root 3 is 3. So you have rationalized the denominator. Now see the denominator, it is a rational number now. Yes, so you can say that root 3 is a rationalizing factor of root 3. Okay, so the new term which you are learning now is rationalizing factor. Clear? So you can say that root 3 is a rationalizing factor of root 3. Okay, so suppose you multiply two irrational numbers and you get a rational number, then each of the irrational numbers are called rationalizing factor of each other. Okay, suppose you multiply root a into root b and you get some rational number c. So root a and root b are called rationalizing factors of each other. I hope this is clear for you. Now let us take this next example. Now suppose the same example, 1 by root 3, you have to rationalize. So you can multiply it by root 12 by root 12. Yes, so using these identities, you can say that 1 into root 12 is root 12 divided by root 3 into root 12. Using this identity, root 3 into root 12 is nothing but what? So it is root of 3 into 12, which is nothing but root 36. Yes, so this is root 12, which is irrational number, divided by root 36. You can solve it, it is nothing but 6. Root 36 is 6. So you have rationalized the denominator. So you can say that root 12 is a rationalizing factor of root 3 and root 3 is a rationalizing factor of root 12. Yes, so let me summarize here. So we have seen that root 3 is a rationalizing factor of root 3 and root 12 is also a rationalizing factor of root 3. Okay, but in general we consider the lowest form. You can see that root 3 is the lowest form. So the rationalizing factors can be many, but we consider the lowest form. Okay, so whenever you get a question to rationalize the denominator, you consider the lowest form and you multiply and divide with the lowest form to rationalize the denominator. And the rationalizing factors can be many. Now for example, we have taken root 12 and still you got a rational number. So you can say that root 12 is a rationalizing factor of root 3. But still we consider the lowest form for solving because it simplifies our calculations. Now in the previous example, we have seen that we have only one term in the denominator. Yes. So for example, we have taken 1 by root 3. So there was only one term in the denominator. Now let us see if there are two terms in the denominator, how can we rationalize it. So for example, 1 by 7 plus 4 root 3. a question 1 by 7 plus 4 root 3 is given to you and you have to rationalize the denominator. So how do you do it? Simply you can multiply it and divide it by 7 minus 4 root 3, okay, and 7 minus 4 root 3. Clear? Now whenever you have plus in the denominator, between the two terms of the denominator you have plus, so simply take minus, okay, and if you have minus between the two terms you take plus, okay, that becomes the rationalizing factor of the other number, okay. So you can write rationalizing factor of 7 plus 4 root 3 is what? Is 7 minus 4 root 3, okay. Now let us see how. Now it is 1 into 7 minus 4 root 3 gives you 7 minus 4 root 3 divided by, now look at this one, the denominators, they are of the form a plus b into a minus b, and you know that the answer is a square minus b square. You have learned this identity, yes. So a plus b into a minus b is a square minus b square. So it is in the form of a plus b into a minus b, and here what is a? A is nothing but 7, yes, and b is 4 root 3, okay. So keeping this identity in mind, let us solve this now. So this is nothing but, the denominator is nothing but, you have to bring it in the form of a square minus b square. Here a is 7, so it is 7 square minus b is what? 4 root 3, 4 root 3 whole square. So this is the denominator, okay. So it is nothing but 7 minus 4 root 3 by 7 square is what? It is 49 minus 4 root 3 whole square. Now this is of the form a into b whole square, yes. So you can distribute the power, it is a square into b square, agreed? Yes. So here also it is 4 square into root 3 whole square, yes. Now 4 square is nothing but 16 into root 3 whole square is what? It is simply 3. So 16 3s are 48. So this is 48. The entire value is what? 48. We have solved here. So the answer is 7 minus 4 root 3 divided by 49 minus 48 is 1. Okay. So the denominator is rationalized and you can write it as 7 minus 4 root 3. Simply, since the denominator is 1, you can take it as 7 minus 4 root 3. So always using this identity we can rationalize the denominator. So whenever you have a plus, you will take minus, and if you have a minus between the two terms, you will take plus, so that you can use this identity and you can bring it in this form, okay, a square minus b square. Now few properties are mentioned in your chapter, so let us see them. So we have already discussed this root a b is nothing but root a into root b. In the previous problem when we are solving, we use this identity, yes. So root a by b is nothing but root a by root b. This also you have learnt in your previous classes and we are going to use them in our problems. For rationalizing the denominator, we use most of these properties, okay. And look here, root a plus root b into root a minus root b is a minus b. This is nothing but, just now we used a formula, a plus b into a minus b is nothing but a square minus b square, yes. So instead of a, we have used root a, okay. Instead of b, you are using root b. So instead of getting a square, you got only a, okay. This is the standard form. You have to remember the standard form, and if you substitute root a in the place of a, you will get again the same answer, okay. And now here you see a plus root b into a minus root b is a square minus b. This is also of this form, okay. From this standard form only you can derive this also. Here a is taken as a but b is taken as root b, and which is why you got a square minus it is b, because you have taken root b, okay. Always remember the standard form. Now root a plus root b into root c plus root d is root ac plus root ad plus root bc plus root bd. This is nothing but distributive property, okay. So you can write this as root a into root c plus root d, okay, plus root b into root c plus root d, okay. And then this root a is distributed to both these things and root b is distributed to these things, okay, and you get these terms, clear. So this is simple distributive property. And then look here, it is a plus b whole square. This is of the form a plus b whole square. What is the formula? It is a square plus 2ab plus b square, yes. Now compare this is a plus b whole square, so it is a square. Here you have root a, root b. Instead of a, b, you have root a, root b. So this a square became a. Since it is root a whole square is nothing but a. So it became a. And root 2ab, it is 2 root ab. Again here it is 2 root a root b. Okay, and from this identity, root a into root b is root ab. So we have written in this way. Clear? Plus b square is, here it is root b. So b square became b. Clear? So I suggest you to always remember the standard forms. The standard form also has a proof. Okay, so remember the standard forms, and all these are nothing but the derivations from the standard form itself. And maths is all about logic. So everything you do has a logic. Now you don't have to just mug up all these formulas. You just go logically. It is just substitution and you'll get the answers. And what is the seventh one? Just look at the sixth one. Root a plus root b whole square is equal to a plus 2 root ab plus b. Yes. So if I bring the square to the other side, it becomes what? It becomes square root. Yes. So this square goes and it becomes square root. Now look here. This is square root of, just compare it, a plus b plus 2 root ab is equal to root a plus root b. Clear? So the same sixth identity you have converted into seventh. Just you have removed the square on one side and you have written square root on the other side. Now it's your time to check your understanding with do it yourself. So find the value of x plus 1 by x if x is 2 plus root 3. Okay, now what is 1 by x? 1 by x is nothing but 1 by 2 plus root 3. Okay, firstly you take this value, you rationalize the denominator, you will get some value, and you will just add x plus 1 by x. So you know what is already x is with you in the question, and for 1 by x you will get some value. So these two values you will add and you will find the value of x plus 1 by x. In our previous classes we have learnt laws of exponents. Do you remember? So just recollecting. So a power m into a power n is equal to a power m plus n. A power m whole power n is equal to a power m into n. Yes, and a power m divided by a power n is equal to a power m minus n. Okay, and a power m into b power m is equal to ab whole power m, and a power 0 is what? It is 1. A power minus n is 1 by a power n. Okay, so this is what you have learned in your earlier classes, 8th class, and there the condition was where a, m, n all belong to integers. Yes, and where a is the base, m and n are exponents. Okay, but here let us see if these exponents can be extended to real numbers or not. They can be comfortably extended to real numbers also. The base should be a real number, it can be a real number, and the exponent should be rational numbers. Okay, then you can comfortably apply the same formulas to real numbers base and rational numbers exponent. So let us see few examples. Now let us take an example to 1 by 5 into 2 by 3. Okay, it is of the form a power m into a power n. Yes, so the identity is a power m plus n. Yes, so here also it is 2 power m is what? 1 by 5 plus 2 by 3. Okay, now it is 2 power. Now taking LCM here, it is 15, and this is 5 3s are 1 3s are 3 5s are 2 5s. I hope you are comfortable in taking LCM. So this is 1 into 3 is 3 plus 2 into 5 is 10. So this is 2 power 13 by 15. Okay, so you can apply the law of exponents to any problem which is given in this way. Now it's your time to do it yourself. So find 7 power 8 by 3 divided by 7 power 6 by 3. It is of the form a power m by a power n. So apply that identity here and try to find the value of this. So just observe these examples. 2 square is 4, 2 cube is 8, 2 power 4 is 16, and 2 power 5 is 32. Now what does this mean? So 2 square is 4, which is nothing but 4 power 1 by 2 is 2. Do you agree? Which is nothing but root 4 is 2, as we all know. Yes, root 4, this is square root of 4. So square root we have written in the form of 1 by 2. Okay, clear? Now similarly, can I write in this way? 8 power 1 by 3 is 2. Okay, so it is nothing but cube root of 8. Okay, so this is square root of 4. The same square root I have written in this form, 4 power 1 by 2. The same cube root I am writing 8 power 1 by 3. Okay, now this is nothing but you can write from this as 16 power 1 by 4 is nothing but 2, or you can write it as 4th root of 16 is what? It is 2. Yes, and here you can write 32 to the power 1 by 5, or you can write 5th root of 32 is 2. Okay, so generalizing, if there is a number a power n is equal to b, okay, so you can write b as b power 1 by n is nothing but a. Okay, a power n is b, which implies b power 1 by n you can write as a. Okay, so 2 power 5 is 32, which implies 32 power 1 by 5 gives you 2. Yes, the same thing we have generalized and we have written in this way. Clear? Now let us see what are surds. Now let us talk about surds. If n is a positive integer and it should be greater than 1, and a is also a positive integer, then this form nth root of a, or this can be written as a power 1 by n, as we have learned in the previous examples. So this is called surd. Okay, but the condition here is that a should not be the nth power of any number. Okay, for example, we have seen that 2 cube is 8. Okay, that means 8 is the third power of 2. Okay, so you cannot say that cube root of 8 is a surd. Why? This is not a surd, because 8 is third power of 2. Okay, and you cannot say that third root of 8 is a surd. Okay, but the same example, if I say 4th root of 8, yes, now 8 is not the 4th power of any number. You cannot write 8 as 4th power of some number. Yes, so this is a surd. Understood the difference? So for example, let us take another example. 3 power 3 is 27. Yes, so which is nothing but cube root of 27 is 3. Yes, so this implies cube root of 27 is 3. Now you cannot say that cube root of 27 is a surd. This is wrong, because 27 is the third power of 3. Yes, here in this example the value of n is what? 3. Yes, and the value of a is 27. Now here a is nth power of this rational number. Okay, so this a can be expressed as 3 cube. Okay, which is nothing but you are expressing a as nth power of a rational number. Okay, here the value of n is 3 and you are expressing the value of a as nth power of a rational number. So that is the reason this cannot be taken as a surd. Now I hope you understood the difference between a surd and a number which is not a surd. Yes, now tell me, is root 4 a surd? And also tell me, is 4th root of 16 a surd? So tell me and let me know your answers in the comment section below. This brings us to the end of this chapter, and I hope you enjoyed learning your chapter 1 of class 9. If yes, then let me know in the comment section below. Tell me, how did you like this chapter? How did you like the videos and the classes in the comment section? And also give this video a big fat thumbs up. Share it with all your friends so that even they can learn. And don't forget to subscribe, because subscription is free of cost and you will not miss any video if you subscribe to the channel. So we are doing a lot more than just explaining the chapters to you on an online platform. So do connect with us, do text us to get your worksheets. Thanks for watching.